Hello and welcome to the second tutorial about the function blocks within the mock logic. After you got to know the function block speed crosscheck in the last session, we now take a look at the function block speed monitor. This is the central block for all speed and direction monitoring in an application. At first, I want to give you an overview of the different in and outputs of this function block. The first input at the speed monitor is the input motion. Here the block gets all the information provided by the encoders. The other 6 inputs are optional. By using the input standstill acknowledge, the internal standstill detection is extended by analyzing an external signal. With the add of inputs enable forward and enable backward, the permitted movement direction can be activated. With the optional input speed enable ID, you can select the permissible speed limit. If the current speed at input motion is higher than the selected speed limit, the output monitor status goes low. At last, there are the optional inputs slope select 0 and slope select 1. They make it possible to select between 4 different slopes, which monitor the transition from one speed to a lower speed. Now, the outputs. The output monitor status is normally high. It goes low if one of the following monitoring functions has the result 0. Monitoring of the reduced speed selected via the input speed enable ID, monitoring of the maximum speed, and direction monitoring. The output slope enabled is high as long as the speed slope is active. To indicate the direction, there's the output direction status. 0 means forward and 1 means reverse. The output standstill indicates if a standstill is reached. In this context, it goes high if the standstill conditions are met. This happens if the motion speed is slower than the standstill speed for at least the duration of the standstill acceptance time, or the standstill position window is not exceeded. Moreover, there are also the outputs speed status ID and max speed enabled. Speed status ID outputs the current speed range of the drive. And the output max speed enabled is high if the highest speed range is activated by the input speed enable ID. With the add of these in and outputs, plus the appropriate configuration, this function block can perform the functions safely limited speed, safe speed monitoring, safe direction, and safe operating stop. Now let me explain the block in more detail. So we start in the hardware configuration of the Flexi Soft Designer. It's the same hardware like in the tutorial about the function block speed crosscheck. Therefore, we go straight in the mock logic. Here the function block speed crosscheck is still located in the configuration area. Now we switch in the left sidebar from inputs to function block and select the function block speed monitor and place it in the configuration area behind the speed crosscheck. At first, I connect the input motion with the output motion from the speed crosscheck. Now the block speed monitor gets all the information which is provided by the encoders after the information was checked by the function block speed crosscheck. If only one encoder is used in an application, the speed crosscheck isn't necessarily required. Then the encoder signal can be connected directly to the input motion of the speed monitor. Now, after the two function blocks are connected to each other, we can take a closer look at the configuration of the function block speed monitor. With a double click on the block, I open the configuration menu. The starting page overview appears, and we see the current configuration of the speed monitor. In the first tab Units, you have to define the unit which is relevant for the speed and the position values. Please note that the defined units must match with the motion type of the encoders and with the configured unit in the function block speed crosscheck. Otherwise, the block speed monitor turns orange and the configuration becomes invalid. Now we will take a look at the configuration of the speed limits. In this context, we jump to the next tab, max speed. Here you can determine what maximum speed may occur in your system or should be permitted. The opposite of the max speed we can find on the tab standstill monitoring. Here we can set the standstill speed, which defines up to what speed a standstill is detected. Moreover, we can set a standstill acceptance time. This time defines how long the speed must be continuously below the standstill speed to be considered as standstill. Therefore, it prevents, for example, that a standstill would be detected if the drive only changed its movement direction. Another option offers the standstill position window. By enabling the position window for standstill monitoring, you can define which relative position change is still considered as standstill. As long as this is true, the speed is irrelevant. Last but not least, we have the possibility to enable the optional input standstill acknowledge. This input can be used to extend the internal standstill detection by an external signal. Therefore, the standstill will only be indicated at the output standstill and speed status ID if the standstill condition is met and the input standstill acknowledge is high. Next, we switch to the tab reduce speeds. Here we can set up to 9 optional speed limits. The previously configured values for the max speed and the standstill speed have automatically been transferred to this tab. Now you can define further speed limits by using the input field. By clicking on the plus icon, the entered value is added to the speed limits. These configured speeds are assigned to speed IDs, which are arranged ascending like the speed values. That means the highest speed always has the highest ID, as you can see here. Independent of which speed range is currently active for monitoring, the current speed range with which the drive is operating is output via the output speed status ID. For the configured speed limits in this example, that means speed range 1, which is set with the standstill speed limit, is output if the motion speed is equal or smaller than the standstill speed, and if the standstill position window isn't exceeded. As long as these conditions are met, the output standstill is high. Speed range 2 is output if the motion speed is greater than the standstill speed and if the motion speed is equal or smaller than the reduced speed 2. Speed range 3 is output if the motion speed is greater than the reduced speed 2 and if the motion speed is equal or smaller than the reduced speed 3. And the speed range 4, which is set with the max speed limit, is output if the motion speed is greater than the reduced speed 3. In our example, only 4 limits are configured. If more speed limits are set, then the speed ranges behave according to the same principle as the conditions of the limit reduced speed 2 and reduced speed 3. In the current tab reduce speeds, there is still the option to enable the input speed enable ID. With this input, it's possible to select and activate a speed limit. If the current speed on the input motion is higher than the selected speed limit, the output monitor status, which is normally high, goes low. Additionally, the input speed enable ID triggers the output max speed enable, which goes high if the highest speed limit is activated. Let's go further to the tab slope for speed limit transitions. Here we can define up to 4 slopes by enabling the option with delay. This allows the permitted speed to be reduced evenly at the configured increment from a higher to a lower speed limit, instead of immediately switching to the lower speed limit. Therefore, we can define a delay till the start of the slope, as well as the speed reduction and its duration. After that, the system calculates automatically the speed of the slope. Depending on the number of slopes, up to 2 additional inputs can be enabled, which are slope select 0 and slope select 1. If only one slope is set, no additional input is required. it simultaneously means that only this slope can be used to reduce the speed. If two slopes are used, then the additional input slope select 0 will be enabled. And if 3 or 4 slopes are set, the input slope select 1 will be enabled in addition to the input slope select 0. This signal combination of the inputs slope select 0 and slope select 1 shows how the 4 slopes can be selected. If both input signals are low, slope select 1 will be executed. If input slope select 0 is high, while input slope select 1 is low, then slope select 2 will be performed. To execute slope 3, the input slope select 1 has to be high and input slope select 0 low. And slope 4 is executed if both inputs are high. No matter what speed slope is currently active, the output slope enabled is high as long as the slope is executed. Let's move on to the tab Direction Monitoring. Here it's possible to activate the optional inputs Enable Forward and Enable Backward. By using these inputs, the permitted direction of travel can be enabled. If an input isn't used, then the associated direction of travel is always permitted. The output direction status then indicates the direction. If the direction of travel is positive, then the output direction status has the value 0. If the direction is negative, the output has the value 1. While the direction of travel is positive, the output monitor status changes from high to low. Now we have seen all the important configuration possibilities of the speed monitor. The last two tabs, I/O Comment and Report, I have already introduced in the previous tutorial about speed cross-check. We save the configuration by clicking on the OK button. So that's it for the tutorial about the function block speed monitor. Now you've got to know the in and outputs as well as the configuration menu of the function block speed monitor. At this point, I'd like to mention that if you need further information, you can take a look at the online help or the operating instruction on sick.com/drive-monitor. In the next video, we are going to take a look at the converter function block UART to Boolean converter, which is particularly important to route signals from the MOC logic to the CPU logic.